what makes CBS Field Services different from other electrical testing companies. And I'm just going to go through a brief explanation of that. And it depends. It depends on a lot of things. It depends on the people that you have, it depends on processes and standard operating procedures. It depends on whether you're national, regional, or local support. Depends on resources, and I believe it also depends on the solutions and how people go about offering those solutions. So let's talk about people really quick. I would be lying to you. You would roll your eyes if for a moment I told you that we had the best people, the smartest people, the brightest people. We do, though. We have different people, and that's one of the things that does make us different from other electrical testing companies, is the fact that we just have different people. We have some different insights, some different intelligence, and some different eyes, and so we can see the world sometimes in a different way. We see problems in a different way, and this story is going to be a great example. Another electrical testing company failed this circuit breaker, and you can probably notice that the B-phase pole is discolored from a lot of heat being generated by a bad connection. The other electrical testing company basically said, it's a bad vacuum bottle. You're going to need to replace the entire pole assembly, new bottle, a pretty expensive repair, truthfully. I was called in to try and help evaluate that because, as Justin mentioned, we've got the vacuum bottle interrupter organization. And in the process of looking at that and doing my own troubleshooting, it was determined that the bottle's not the high contact resistance point. It's the flexible strap between the run back of the lower portion of the breaker to the lower portion of the bottle. And that's the picture above the breaker run backs. And so instead of having to replace the entire pole assembly, a new vacuum bottle, all of the problems and challenges that go with that, and cost really is what it was about, we were able to fabricate, or actually I think we found this part in our stores, and we're able to repair this breaker for much less than was originally thought. So, that's one of the things that we got to do and that we find that we do well. So let's talk a little bit about process and standard operating procedures. Now, no company gets to the size that we are, and a lot of our competition are, without having great processes and some great standing operating procedures. I know that one of the things you mentioned was test reports. Well, we have test reports that flag problems in the field so that the technician cannot overlook them. And then these things can be brought up to our clients. And that's where I got in the background there, I've got our quality assurance matrix that we like to use. And this matrix allows the technician to say, hey, I've got this problem. Here's the steps I need to move through to ultimately bring this problem to the attention of the customer at the time of the outage going on, because there's nothing more frustrating than getting a report back a month later and finding out that you had a problem with a breaker that you and or your company could have fixed at that time. Or like I say, we could bring in another piece of equipment from all of our vast resources. So once again, very important to get real-time evaluation and have this quality matrix. The other thing is the communications that I mentioned, communicating with the customer, communicating with you and your team that there is a problem, or there's not a problem, or there's an opportunity for an improvement to be made. And once again, communicating that back to you. And then finally, continuous improvement. And I'll tell you a story. We had an outage going on. It's a very large outage. It spanned many, many weeks that we had a system basically, I'm going to call it an abnormal condition because we were in the process of doing maintenance. So there's a lot of switches and breakers and what I'll call, once again, not normal states. And the client didn't have, I guess, a clear understanding of the condition of their system. So as the outage was starting to draw to a close, they were starting to test some of their new equipment. And in the process of turning on some of this equipment and ramping it up, they tripped a breaker because the main breaker and the tie were closed, the other main was open, and the system wasn't really designed to carry all of that load on the one main. And so the main breaker tripped, causing some headaches and some frustrations, and ultimately, once again, led to us improving our method of communication so that every day now, if we leave a system in an abnormal condition, a condition is going to potentially cause normal operating problems, we make sure we communicate that via email to the client so that they know where their system's at. So once again, that's a great example of how we've learned. And speaking of learning, we're learning about how to become a growing national company. But one of the things that myself and all of the guys that I work with are excited about is we're still keeping it local, right? So if you're in Michigan, if you have an opportunity in Michigan, yes, we're a national company, but we've got a local presence and local staff that is motivated to make sure that they're taking care of the client. I don't like the word mom and pop, but like a mom and pop, that level of connection right? And ultimately, because of that level of connection on the local level, in the local areas, through the regions, you're never more than 2 or 3 phone calls away from, myself, a VP, another VP, the president of the company, Dan Hook. I mean, it's a very shallow organizational structure, I guess is the easiest way to put it. So I say that helps avoid confusion. And ultimately, like I say, it allows us to both have small teams that can attack projects like we did here. That bottom picture is myself and a group attacking some breakers that came up on short notice for a industrial customer. And like I say, we were in there doing MAC testing on Easter Sunday. Or sometimes we got to staff up and bring people from the West Coast, from North Carolina, from Florida, from Michigan, all into one team. And once again, attack larger shutdown opportunities. Now, resources. This is one thing that Justin's mentioned and that Jason is going to wrap up with is when we do find a problem, when we're doing that quality matrix and we find, once again, a bad fuse, trip unit that's got a failure, or an MCC bucket that's, once again, needs to be replaced because of some form of failure. We have access to all of those needed now suppliers. So whether it's Monster Fuse, Arkansas, breaker, where they do the MCC buckets, or solid state exchange repair for trip units. We have access, one phone call access to all of those opportunities to find resources and once again, fill those needed now requirements. Let's talk a bit about our solutions now. Our solutions range from acceptance testing to maintenance testing. Now, once again, I know that you guys are planning some system upgrades, and this is a great time to do acceptance testing. And I'll tell you a quick story about how recently we were working on this gear that's behind me in my background, that we were working alongside the manufacturer and doing our separate commissioning. And of course, the manufacturer was giving me a bit of a stink eye, if you will, about like, well, we're here to test this. Why are you here to test this? And as we both came to learn, and I knew this, is that we test different things. I'm looking at, the holistic view of the switchgear. I'm not just looking at, the box. I'm looking at what the box connects to, both upstream and downstream. And so that's that holistic view that we take to acceptance testing. We're not just there to test the box. And once again, even through that process, we did some testing that the manufacturer typically doesn't during an acceptance testing, say primary injection. And once again, through the primary injection process, we found neutral CTs that were wired incorrectly. And there's no checks the manufacturer was planning to do that would have found that. And of course, it was tested at the factory, right? I always love that story. Maintenance testing. You guys are familiar with maintenance testing. I'm not going to go on and try and explain all the maintenance testing things that we do well, but I think you understand that, great maintenance testing, whether it's a small team, a large team, a big outage, a small outage, the paperwork, and we already talked about the communication about the findings is so important, and how we address those findings immediately so that we can bring in the resources if we need to. And I'm going to wrap up by talking about system monitoring and modernization. I get a call at least once a month from somebody that hasn't had a problem for 10 or 15 years. And last week they had something fail that caused an unplanned outage that caused them some frustration. And now this week they'd like to start monitoring their system so they can figure out what it was that happened. And to me, that's just mind blowing, because you hadn't had a problem for 10 years. You had a problem last week. What makes you think you're going to have a problem this week or next week or next month or the next 6 months? So once again, me coming in with temporary monitoring is always, I think, a poor solution. We're putting a Band-Aid on the symptom, not actually attacking the problem. The problem is you want information all the time when you need it. And with modern relaying, with modern metering, it's relatively inexpensive to replace old analog meters or install an entire new system and then have monitoring all the time, right down to your desktop. And that's one thing that I think is an opportunity that's going unutilized. And of course, I can't speak specifically to your all systems, but I want to plant that seed to think about. And then finally, the other thing is arc flash mitigation. And arc flash mitigation, not using arc safe gear, that's the last line of defense. But what can we do to mitigate it by either installing upgraded relaying or complementary arc flash reduction relaying? And once again, there's the light sensors, there's pressure sensors, there's fiber optic lines, there's various versions of that. And Multilin makes products, SEL makes products, and I'm sure there's other manufacturers out there that do. But once again, by installing these products on your system, we can basically almost eliminate the arc flash hazard. And the other thing I should mention, I would like to mention is high resistance grounding. I don't know if you guys have any systems that have high resistance grounding, but if you do, since most arc flashes start face to ground, a high resistance grounding system prevents that explosive release of energy because it limits the fault current in a phase of ground fault to 5 amps. So there's no explosion. And of course, the alarms go off to tell you that you've got a problem. But the nice thing is that one, there's no arc flash event. The process continues to run and allows you time to troubleshoot it and identify it without having to shut down everything. So I want to wrap up and just say, we're going to have some time at the end to talk about where your issues end, what maintenance things are getting undone or are not consistent across all of the facilities, where there's a lack of redundancy possibly in your systems. Like I said, I mentioned the monitoring. If you've got some processes or some systems that are going to be upgraded, what about acceptance testing? And finally, once again, whether it's via relay or via high resistance grounding, what can we do to help you guys with arc flash mitigation?